Year 12 end of year exams 2025 paper 2 question 1. Which of the following is an SI unit for stress? So stress has a formula, force of an area, force unit Newton, area unit meter squared. I didn't look left and glance left at the answer, so I was expecting all of the answers to be in base units. I carried on, expanded out, kilograms meters per second squared. That's the expansion of newtons as mass times acceleration, where this is mass and meters per second squared is acceleration. Meters squared at the bottom, tidy that up to give you kilograms meters to the -1, seconds to the -2. That is not an option in either of those. So looking back, glancing, you see newtons. I've gone back there and I can see Newton per meter squared. Okay, so the answer is D. Question 2. We have got a question that is looking at diffraction. We've got wavefronts coming in, passing through a gap, and they haven't shown the diffraction pattern on the other side, but we know that the wavelength is the distance between two wavefronts, and in the first option A, the gap size is similar to the size of the wavelength. Therefore we know that when this is the case, we get noticeable diffraction, and the diffraction wavefronts are semicircular. Same with D, the wavelength here incoming is similar to the gap size, so we are going to get semicircular wavefronts, and in part C the wavefront is bigger than the gap size, so we're going to get a significant amount of diffraction, or a possibility of none of it going through because the wavelength is too large and you get only reflection. So semicircular on A and B, A and D, and C potentially, but also potential reflection. B, gap size is small compared to the gap size is big compared to the wavelength, and here, as we know, that the wavefronts are a little bit stretched out and not semicircular, so the answer is B. Question 3, we are looking at what quantities should the student measure directly. Now it's an experiment to determine Young's modulus. You have done this as part of a required practical. The question says student adds known masses. Whenever we have known masses with values written on them, often we don't go to a mass balance to confirm that mass. We just take it as it is, and the other measurement, the measurement that they've taken is extension. Now, which other quantity should the student measure directly? That would be looking at the formula for Young's modulus, stress over strain. Stress is force over area, so this known mass is mg in that F. A is your cross-sectional area, so we will use a micrometer to find the diameter of the wire. Micrometer doesn't directly measure the radius, so we have to halve the diameter to get the radius, but we actually measure the diameter, so C and D are wrong. And the next thing, because they've already talked about extension at the bottom here with strain, x over L, L is the original length, so it's the diameter and the original length are the other quantity that should be measured directly. Question 4, we have a ray incoming and then potentially reflecting, totally internally reflecting, so none of the light gets through. One of the conditions is this incoming angle has to be greater than the critical angle. So looking at the options, that gives us A and B, so we've got 50-50 if we have not remembered how the refractive index operates. Now the refractive index of where this ray is heading to is lower than where it is currently at. Okay, so it's going to a lower refractive index, so that means refractive index of X is greater than the refractive index of Y. Refractive index of X greater than the refractive index of Y. And also with the formula that's confirmed, because if Y was bigger than X, then you will not get a value for sine theta, critical angle, as the function sine varies between 1 and -1. Question 5, we have two springs in series. They are identical as mentioned in the question. They have a force of 45 newtons pulling down on them, and we have been told that the overall extension is 15 millimeters, and they've asked us to find the stiffness, i.e. the force constant, in newtons per millimeter. So we don't really need to convert that millimeters to meters. Now, because they have said in the earlier part of the question the springs are identical, the force constant in both of the springs is the same, i.e. the stiffness, and because they extend overall by 15 millimeters, so the sum of the extensions of the two is 15, that means that this first spring will have extended half of 15, and this second spring would have extended half of 15 as well. Now this force of 45 acts along both springs, and the line of action will get the same force. So the line of action with the force acting downwards is vertically upwards, and along that line that force will be the same all the way through. So all particles will get pulled by a force of 45 newtons. In other words, the one spring gets pulled by 45 newtons, the other springs also gets pulled by 45 newtons. So we can consider this question by looking at just one of the springs. So if I know that this spring here has been pulled by 45 newtons and it's been extended by 15 over 2 millimeters, then K is F over X, and 45 over 15 divided by 2. The reason why I haven't said 7.5 is because they haven't written that in the answer, so I'm leaving it. Now rearranging that, tidying that up, looking like the answers in A, B and C and D, K is equal to 45 times 2 over 15, and the answer is D. The other way of answering this question is looking at the overall system. That means that the overall force, which is 45, and the overall spring constant, and the overall extension. Now, the overall spring constant, because they are in series, this is the same as if you were looking at resistance in parallel. So that formula there is similar to resistance in parallel. So series springs, similar resistance in parallel. So 1 over K overall equals 1 over K1 plus 1 over K2. They're both the same values, identical springs. So we will get 1 over K overall is equal to 2 over K. And rearranging K over 2, putting that in here, the overall spring constant is a spring constant of one of them divided by 2, and the overall extension is 15, and the force acting on both springs is 45. So therefore rearrange that and we get the same spring constant K, because K is the individual spring constant for each spring, and that's the same answer, D.